Hi, we're Team L1G1, and this is PiSecureX, a modular smart home security system built using Raspberry Pi.
Integrating a home security system in your home can drastically decrease the risk of home invasions and break-ins. However, many homeowners avoid installing them due to the high costs and limited flexibility, highlighting the need for more affordable and customizable security solutions. Our system aims to implement a more affordable and adaptable home security solution to address rising break-ins and the limitations of existing systems. It will feature real-time facial recognition to grant access to an individual's home, as well as motion detection that records activity automatically, and most importantly, a user-friendly interface for remote monitoring and control. All data, such as video footage, face profiles, and passwords, are stored securely in a centralized database for easy access and management.
Now let's meet the team behind PiSecureX and highlight each of our contributions. Ahmed worked on the backend, developing the server, camera API, and database models. Abid was in charge of the user interface, creating the GUI with Tkinter and setting up real-time communication using WebSockets. Dina handled the doorbell functionality and motion detection. Farida focused on facial recognition, image capture, and testing the camera system. Brendan integrated the server motor and keypad, managing key aspects of the hardware setup. Each of us brought a key piece of the project together to build a complete, smart solution.
PiSecureX uses a distributed architecture with 5 Raspberry Pis, each handling a specific task: facial recognition, motion detection, video surveillance, database management, and system control. This modular setup allows tasks to run in parallel, improving fault tolerance and allowing for a scalable solution. This was done by allocating each member a role as server, client, database, control, and camera. The next slides will detail the role and operation of each Pi.
PiSecureX features a secure login system that grants access to a real-time dashboard. This displays live camera feed, motion alert, and notification. Users can view recorded footage through the video playback panel with standard media controls. The control dashboard allows facial recognition registration, manual door locking and unlocking to provide a user-friendly security management experience.
The backend is built with Python and Flask, handling HTTPS requests and user authentication. It uses a module design with separate layers for logic. We have Flask, which uses RESTful APIs for the server with basically using module routes. We have gUnicorn, which is a production-ready HTTP server. We have Celery and Redis, which is used for Flask rate limiting. We have SQL Alchemy, which is an ORM to interact with a PostgreSQL. JWT tokens, which for token-based user authentication. The OpenSSL, which is TLS and SSL certificate generation for HTTPS. The PostgreSQL database stores user accounts and facial data, ensuring secure and organized data management.
The control Pi handles the physical access control using a servo motor and a keypad. We use the SM2309S servo motor, which unlocks and locks the door by rotating 90 degrees. It runs on a 5V and is controlled by pulse width modulation through the Raspberry Pi. For user input, we use the 4x3 matrix keypad that allows users to enter a PIN to request access. It runs on 3.3 volts and communicates with the Pi using GPIO-based digital input across 7 pins, which consists of 4 row pins and 3 column pins. Both components work together to manage secure physical access and interact with the system via HTTPS-based communication.
The camera plays a central role in PiSecureX, supporting both facial recognition and video surveillance. It continuously monitors the entrance and captures images when motion or a face is detected. These images are processed using OpenCV and the face recognition library to identify known individuals from the database. If a match is found, access is granted automatically. Otherwise, the footage is stored for later review.
The camera module is built using PiCamera 2, which enables real-time image capture and seamless integration with OpenCV. It also communicates with the backend to log activity and trigger appropriate actions, making it essential for access control and system monitoring.
Here's an overview of how PiSecureX functions as a complete system. It shows different components like facial recognitions, motion detection, and how door control interact with each other through the central backend. Now we'll walk through the process flow for each key use case in the PiSecureX system. This will include access control through the facial recognition and doorbell, which captures footage during motion or access attempts, automated door control where the system locks or unlocks the door based on recognition results, GUI video playback, allowing users to review recorded footage easily, and finally, GUI-based facial recognition, which walks the user through adding new authorized individuals to the system.
Abid, Come on in, you don't need to knock. Your face is already registered. Brandon! Let's register your face. Go stand in front of the camera. Let's register your face.
Alright.
Okay, so first we're gonna put your name, Brandon. And now let's get you in the frame.
Hello?
Hi, I left something at the door for you.
Okay, let me go check. Oh my god, it's not there! Let's see who took it. My god!
Hey Brendan, do you want to test your PIN code?
Yeah, sure.
So your code is 1234. Now press enter. Perfect, you entered the correct PIN code. Okay, do you mind testing the incorrect PIN code?
Yeah, sure.
Okay, and now we have the red LED. That means you're an intruder. Hello, so here's our application. We have our GUI running. We have our camera and control Pis also running on different Raspberry Pis. Here we have the home page. It tells us some information, and we can also view the camera from here, where we're going to view it later. We have the profile, where it tells you also some more information. Here from the settings, we can change our password, and we can also have some camera settings. And then in the Meet the Team, we have our different team members. And we have Ahmed and the rest of the team members. In the control Pi, we have also some settings for adding a new pin, resetting all pins, lock door, unlock door, and so on. And again, finally, for the most important, the live camera. Right now, it's just recording us with my legs kind of moving, okay? And that's it.
Moving forward, we plan to add SMS and mobile app notifications for real-time alerts and improve accessibility with Cloud Sync for video logs. We also aim to extend the motion detection range for a broader coverage and explore home automation features such as light and thermostat control. These upgrades will enhance system performance and user convenience.
In this project, I was in charge of backend development. I learned how to develop a production-level server with sockets and multi-threading. This helps connect the system components, but most importantly, allows for multiple clients to connect to the same server. Testing the server helped ensure smooth server performance and revealed areas for future improvement.
This project was a great team effort. I worked with on the GUI using custom Tkinter and learned about front-end design and multi-page navigation and real-time system integration. I also gained experience in cross-device communication and connecting the interface to the backend system.
This project was a great learning experience. I focused on system integration using GPIO and threading, and I worked closely with Farida to refine how modules interacted. I gained skills in modular development and real-time debugging on Raspberry Pi.
This project was extremely successful with a strong emphasis on teamwork and communication. I learned a lot on Raspberry Pi camera input, image processing, and GPIO communication, as well as image capture.
This project taught me hardware integration and event-driven programming. I worked on the control board with the keypad, servo motor, and sensors, getting experience with GPIO and I2C and Python.
Thanks for watching our PiSecureX demo. We're proud to have built a working modular system from scratch.